Okay, great. Well, thanks very much. Thanks to James and Andrea for inviting me to give this keynote talk today, and to Adam for his kind introduction. I will be saying a little bit more about GMAP and the RAMP project, and one or two other things presently. So the topic that I wanted to concentrate on in the talk today was to say something about urban analytics, and as noted on the screen here, Adam's already told you that I'm associated with the Turing Institute, but specifically as a program director for urban analytics, although I still retain numerous interests at the University of Leeds as well, as Adam has again kindly talked about. But today I'd like to talk about urban analytics and, well, with the secondary clause, progress and prospects, but just to say a little bit more about where we are with this topic and where we might be going. So in terms of the content that I'll be sharing with you, so a little bit of background, a little bit of history, tiny bit of self-indulgent stuff perhaps to start off with there. Then I want to come on and say a little bit about definitions, and not too much, but tell you a little bit about some of the conversations that have been taking place within the urban analytics community, particularly in and around the Turing, and your thoughts about the content, structure and activities in this program. I'd like to say a little bit more about a couple of examples of the kinds of work that is underway, and one of those will be about the RAMP program that Adam's already referred to, and then just a little bit of concluding a discussion and reflection. Okay, so as I say, I'm going to come back and say a little bit more in terms of definitions presently, but just to fix ideas to start off with, I'll begin with a broad definition from someone who you might think has a pretty good idea of what urban analytics might be all about. So some of you would have seen a couple-page editorial that Mike Batty wrote on the subject a year or so ago in Environment Planning B, in part a commentary on why that journal had decided to change its own subtitle to more of an urban analytics branding. So Mike talks about a set of methods that can be used to explore, understand and predict properties and features of cities. One might say cities and regions. One of the debates about urban analytics, and a slight weakness in the name perhaps, is that it maybe implies that we're only interested in certain kinds of areas. I think actually the topic is much more wide-ranging than that, but of course cities, urban is a convenient kind of label. Okay, so to begin with, I will want to go back even before the times that Adam told you about, and although he did refer to myself being very kindly from the Alan Wilson stable, and indeed I just pulled one slide out for the deck here, thinking right back to my own days as a PhD student, working with Alan, thinking about the translation of problems from location theory into the environment of mathematical modeling and computational simulation. And in the interest of time, I won't go into detail in terms of what we're looking at here, but this is these are some results that I used in my thesis, later published in Geographical Analysis, which was thinking about how you can take so this is one particularly well-known piece of location theory. Von Huenen, German location scientist from the early 19th century, looking at distributions of agricultural location and productivity and the kinds of effects that that might have on the structure, again, not just of cities that might be at the middle of some kind of idealized region here, but the land use and agricultural hinterlands around those cities. So again, without wanting to get progressing into unnecessary detail, we're thinking about how might variations in patterns of transportation or fertility or topography, those kinds of questions, translate into different sorts of structures of cities and regions. And so, one of the simple points I want to make here is that if I think back to Mike's definition, and I've written it down because I can't see it now, we're thinking about exploring, understanding, predicting properties and features of cities and regions, then I think those kinds of ideas are strongly embedded in the sorts of work that you're looking at here. So to make the simple but important point that although we've only been talking about urban analytics as a concept, so you started to hear it frequently and regularly over the last 2 or 3 years, the basic ideas underpinning this discipline have been in play for really quite a lot longer than that, I believe. So that's thinking back to the mid-1980s. Moving on about 10 years, and so this is to some of the times that again Adam was going to have to refer to. So thinking about, let us off the GMAP days, and so I'm going to use a couple of illustrations here just to say 1 or 2 things from a book that we actually wrote in the mid-1990s about our experiences. Just a little bit of an apology here. I'm working away from my office, like all of you. I don't quite have access to all the facilities I'm used to. And you'll notice here I have used my iPhone to take copies of some key illustrations from a book on my bookshelf. And so apologies for any slight distortion or blurring in the images here, not quite what we're used to. But of course, we're all having to try and cope and compensate as best we can in current circumstances. So there was a book here written in the 1990s. And what we're reflecting on here is some of those applications from academic work, which Alan, myself, Graham and Martin Clark, 1 or 2 others were heavily involved in the translation of into more business, governmental, practical settings in the 1990s. And so what this work is about is creating models to inform retail organisations, very broadly viewed or specified public service providers, organisations with geographical, spatially distributed networks of provision of products and services. So the sorts of illustrations we're looking at here in the top centre, we're thinking about how is population, demand, expenditure, again in these examples for a retail product, distributed, centre at the bottom there, we're thinking about how those distributions of expenditure and demand get translated through patterns of flows of expenditure and revenue into retail centres. And in the top right and the bottom right there, we're looking at a couple of illustrations. The top right is actually showing top and bottom. How does the market area, the sales pattern for a retail organisation change if we introduce a new retail outlet? How does that bring in new customers? How does that affect revenue and performance at an existing location? And the bottom right is actually kind of a hotspot analysis for a retail organisation trying to kind of optimize or identify strategically where new locations might be particularly profitable based on the kind of evidence of existing network behaviours and consumer patterns and all those kinds of things. Okay, so some rough and ready illustrations there referring to that sort of work. So to summarise that in broad terms, I think what are we looking at here is we're looking at an approach that combines data, like those distributions of population and demand. Underneath that is actually something like what at times called a pin map, so a customer distribution for a particular retail centre or outlet from some kind of observational or survey data. We're putting that together with some models in the centre that are helping us to predict how those consumers, how those people might end up at retail destinations and what might happen when they're there. And then on the right-hand side, we're generating some insights on that into what an ideal location strategy might look like, or what would happen if I were to perform some network alteration at some particular location. Bottom right's actually looking at a market share pattern, so that's more kind of insight for an organisation thinking about how its network translates into influence on its customers and the market. So, and I mean, I'm going to come back to this in a while, but again, you know, I'm kind of pointing to the fact that what we've got here is a set of techniques, and particularly the models that, you know, are helping us to generate this kind of insight from the data that comes into us. And I think this is into them, and you know, I think this is still already a very urban analytic way of thinking about the world. If I roll forward, you know, right up to actually about a month ago, and this is a little bit of an aside, but I kind of wanted to make the observation. I don't know if anybody else in the room was present at the launch of the National Geospatial Strategy, which took place around about the middle of May, as I recall. And so this is the Geospatial Commission have put this document together, being forward thinking about our aspirations and strategies for developing the geospatial infrastructure of the country. And I was very struck by I've captured some of it here in terms of the ministerial welcome to the document that goes with the strategy, which you can easily find online. Although this was, you know, represented very much in some of the things that Sir Andrew Dillon, the chair of the commission, and one or two of the other presenters were saying about the strategy. So here's a key statement. I think the government seeks to unleash Britain's potential to lead the world in the data revolution. And you know, so I think a very worthy, appealing, you know, kind of logical ambition being stated there. And you know, one of the things that was quite striking for me is that I think that's very laudable, and I totally buy into that. You know, and I just wonder if there's a gap, and for me, there's potentially a gap when you then drill into the strategy, or you hear the way that people actually talk about the things that they're doing, between that kind of very wide-ranging, for me, you know, big picture ambition and the reality, which is, you know, is it actually a case that, here are some illustrations from the report, but take the top left as a good example. You know, what we really want to do is we want to build the highest resolution, you know, high quality, three-dimensional maps of where the pipes are underneath the surface of, you know, the roads and the countryside in the country. And my point is, you know, I hear a lot of people talking about, you know, data infrastructure in terms of the need to acquire data, to do that at great accuracy with resolution, you know, to make it interoperable, to join it together, and all that's, again, fantastic and laudable. But in my opinion, you know, what I still don't hear as much about as I'd like to is, you know, why do we want to do that? What can we do with that data? And, you know, going back to that previous slide, how is that going to help us in our ambitions to be leading the world in terms of our capacity to do things with data? And my argument, I think, would be that there will be a lot of countries, you know, competitors, if you like, in that sort of global context, who will invest heavily and be doing this kind of thing as well. And one of the ways that we want to be seen to be leading and to stay ahead, be at the forefront in that global marketplace, is through the ways that we add value, we go beyond, and we do more than this. So then, just to finish off on linking back to the previous point, I mean, in a sense, I didn't make this explicit before, but the title of the book, you know, kind of has a clue here. You know, where we talk about intelligent GIS, and you know, actually, that in itself builds on some work that we didn't really publish actually, other than in working paper form, but several years before that, where you know, and you have to realise that going back 30 odd years, you know, this is at a time when you know, geographic information science was really just starting to enter the mainstream of research and academic life in geography. But you know, again, here we're already making the point that you want intelligent GIS, you know, model-based analysis, location analysis. What can we bring to bear that's going to really help us to leverage the value from all the trouble that we've gone to start generating these fundamental data sets and assets? And I think that is you know, a point that is worth re-emphasising in the context of a plenary at a GIS Research UK conference. So moving on to the part, and this is a little bit shorter than the first or the third bits. So just to say something a little more about my own kind of perspective on a definition of urban analytics, and you just kind of marking out a little bit the territory and what we're talking about here. So context, to say that the term urban analytics has tended to become much more popular over the last 2 or 3 years, and the urban analytics program itself at the Turing was established less than 2 years ago, in the latter part of 2018. So one of the things that we did last year was that we put together a couple of, call them workshops, but sort of community sessions for people in the Turing partner universities and beyond with an interest in this area. And we asked people to come together to a couple of these meetings, in both of which, as you can see here, we use the terminology of a blueprint, but essentially to encourage people to contribute, to come together in a discussion about, you know, what do we think urban analytics research is all about, where do we see the opportunities and the work and the activity here. Both quite well attended. I think we had about 90 people in Newcastle, and slightly less, but probably 70 for our meeting in Bristol. And I'm not going to go into chapter and verse and drill deeply into specific studies and examples relating to these topic areas. I'm just going to highlight them, and happy to discuss or reflect further in questions if people would particularly like to do so. But these are 8 priority areas that we ended up pulling out of those 2 meetings. And so we can see that, for example, modelling and simulation, I've already said a fair amount, figures prominently in that list. Again, I mean, visualization in a sense is at the heart of GIS, but you will hear people talk more about things like visual analytics, I guess, these days than they did 20 or 30 years ago. Data platforms and data infrastructure, and again, I kind of alluded to that in terms of some of the things that I was saying about the geospatial strategy. You know, clearly, you know, access to and utilization of various kinds of data is a hugely important issue. Data science and AI, I haven't said a lot about the Turing Institute. Some of you will know already, but it is the National Institute for Data Science and Artificial Intelligence. And so in the context of a Turing program, it is very natural to look to data science and AI to think about that kind of methodological side, and you know, what are the new issues and opportunities in that sense. But I think again that's I believe that the theme of the GISRUK conference this year is particularly around AI. So of course that is something that everybody is thinking about in the GIS and analytic kind of context. Data ethics, how you involve the public in what you're doing, have them enthusiastic about it, not suspicious of the things that we are trying to do. Again, often with what is either public data or even better, getting into elements of what might have some kind of more personal or sensitive elements to it is clearly an issue that anybody doing analysis in the current day with real world data, I guess, needs to be thinking about. A focus on applications, I'll come back and say a little bit more about that. Questions of validation, uncertainty, again, they've always been there, and of course, key thing going back to GMAP days, one thing to tell your clients or partners what you think the effect would be of opening, closing a store, merging a network, whatever is one thing. Making sure that it's believable within whatever parameters is another and a pretty important issue. But again, that's not gone anywhere. And the whole dynamics thing again is something that's always interested us as a group. All these problems are dynamic. We're thinking about what's happening in the future as well as what may be happening in the present or the past. Next slide, and I've been kind of toying a little bit with this for quite a while without ever actually, as you can see, having written it down in any particularly definitive kind of way. But what I would come back to when I look at those kind of detailed different priorities and areas is that I think essentially we're looking at three things, or at least bundling them together into three high-level things makes some sense. And okay, I can just move that. So first of all, back to data again. Questions around data platform, but other elements here towards the bottom of the diagram, thinking about the data side of things. Oh, hang on. We're thinking about methods, of course, as we've always been, and again, whereas 30 years ago we might have been thinking more, well, of course we still are, but about space interaction models and discrete choice models and that kind of thing. As I said, now we're reaching more into areas like AI and data science, or Bayesian methods for handling uncertainty, or all kinds of stuff. And we're very focused on the outcomes. What is the relevance of all this kind of thing to our understanding of real world systems in an academic sense, or maybe into more policy kind of environments about how we can evaluate, influence interventions, plans and policies and that kind of thing. So actually, when I'm thinking about how we define urban analytics, and I don't have this in formal words, but these are the three things probably that I would be focusing on. So yes, we've got that set of analytic methods which we're interested in developing and applying, but these days in particular, we're very concerned about the data that we feed into those methods, the whole kind of big data discussion and debate. And I think we are, I think we should be, and of course we all know about impact agendas with research councils and all those kinds of questions, but we should be strongly focusing on the outcomes and what we can do with these methods and data sets. So in a sense, there's a view of urban analytics that I tend to use, which is about, yes, focusing on those methods, but almost as a way of translating the new data sources, the real-time data sources, the big data sources into practical and often policy relevant and actionable kind of outputs from our work. Okay, quick look at the clock, and I can't see anybody else on the screen in front of me, so as a slightly strange contemporary context of trying to work out where you are, but I'm going to take about another 10 or perhaps slightly more, 12 minutes to talk through these examples. So somebody have to send me a message if that's if I'm already outstaying my welcome. But we've got now a session. I imagine that's okay. So a couple of examples that I'm going to talk about. And so one is a project that we've been doing at the Turing pretty much since the urban analytics thing began, as I say, maybe 18 months ago, which we refer to as a digital twin in urban analytics. So I'm going to say a little bit more about that one, and then I'm going to say a little bit more, not too much. Adam and I were involved in a seminar the other day where we spent about 3 hours over this, so I'm not going to go into all the detail on that, but just to give you a little bit of a flavour of these two projects. So just to start with that digital twin example, and again, a number of you will be familiar with this kind of language because it is increasingly kind of prominent and widespread, particularly actually in the engineering disciplines, but starting to very much broader than that. And this idea, in a lot of ways, goes back a little bit further, again, just back to 2017, with this report that was published by the National Infrastructure Commission on data for the public good. So just a definition here from the chair's introduction: a digital model of our national infrastructure, which can monitor our infrastructure in real time, simulate the impacts of possible events, such as a natural disaster or a new train line. Again, I would make the point, if you took the trouble to read that report, which is quite interesting, you might again get the sense that there's a lot of focus on kind of digital data, high resolution data, all those kinds of things that I talked about before, and it might be nice if they actually said a little bit more about the sort of value proposition. But I've picked out this particular quote. It is in there, and it is kind of recognised quite rightly as something that we need to be doing. So the urban analytics digital twin at the Turing, the main part of the project is focused around two kinds of modelling applications, and I'm going to run through these very, very briefly in the interest of time. But one is a microsimulation model, which my colleague at Leeds, Nick Lomax, is primarily responsible for, which we call SPENSER, and the other, due to Adam and his colleagues, well, particularly Mike Bassey, Richard Milton, actually at CASA, which is called QUANT, and is again about simulating flows and interactions, particularly commuting flows within the labour market, and those kinds of questions. So in the urban analytics digital twin, we're taking a microsimulation which looks something like this. And again, in the interest of time, I won't go into any detail on this, but to make the point that what are we doing in the microsimulation? We're representing individuals, households in a fairly comprehensive way. So SPENSER is essentially a microsimulation of the whole country that has 60 million individuals, 20-odd million households, represented synthetically, so not real, but realistic people, which in some ways can just be viewed as a huge list of those individuals, households, and characteristics. So in the example you're looking at here, we have a set of areas, medium-sized super app areas, going down the first column of the table, and then those first couple of individuals there are partners in a household. One of them is age 66, the other 65. They're both British. The first of them, as it happens, is in better health than the second one. The first individual was previously self-employed or working for a small employer, and so forth. And so we use a variety of data sources, and actually the data that you can see in front of you here is synthesized from a combination of the census, various health surveys, and some labour force surveys to put together a picture of a population which may focus on slightly different things according to the kind of problem that you're interested in, but would be of the general character that we can see in front of us here. Okay, that second set of technologies, as I said, is a spatial interaction model or a group of spatial interaction models. And so I'm drawing here just from the home page of the QUANT website, and actually this is quite a nice web-enabled tool, and you can go along with it and play around with it to your heart's content if that's the sort of thing that interests you. But here we're looking at distributions of population, as you can see, distributions of employment, and then we can start to see what the commuting flows between those origins and destinations look like, if you like. So we can see there big catchment areas for London, to a slightly lesser extent the other major cities, and other more concentrated labour markets as we move further down the urban network in the country. So in this digital twin for infrastructure application, we're thinking very much about the ways in which these sorts of technologies can help us in decision making around what could be quite major infrastructure projects and investments. So one example that's been looked at quite a bit is used to be called the Cam-Cox corridor, now seems to be more referred to as the Oxford-Cambridge Expressway. So the idea that we might link up Oxford and Cambridge through around Milton Keynes and other places in that vicinity to create high quality transport infrastructure in that part of the country. So again, and I'll just flick through these, but to say that the work that I'm going to reflect in the next couple of slides is actually coming from a group which is called Mistral, or originally part of the ITRC consortium, which includes myself and Nick in Leeds, but also others in Newcastle, Southampton, and led by Jim Hall actually at Oxford. And again, there's a web link there. You can go and read more about this particular report and the work more generally, should you wish to do so. Part of which is based at the Turing, but a much bigger project behind that. So what we're looking at here is different kinds of scenarios in effect. The top three there are more based on expansion of current settlements, urban settlements, that kind of thing. The ones at the bottom much more around extensive new build and those sorts of options. So what we're pushing at here is how can we use these technologies of understanding the population, understanding their behavior patterns, their flow patterns, but within a model context, so that the kinds of parameters, where is the employment, where is the housing, we can start to move those things around and to get insights into what happens with all that. So we can draw conclusions, so for example in this illustration, about activity on the transport networks as we introduce this new infrastructure. The second example that I quite like is thinking about that more in terms of environmental impact and carbon neutral agendas, those kind of questions. So here we're seeing that environmental impact being reflected in various different scenarios and contexts. Okay, so that's just to give you a very high-level idea of some of the work that we're doing in the urban analytics, digital twin and infrastructure planning space. And so, as promised, the second example I've said a little bit about is the work with the Royal Society. So Rapid Assistance in Modelling the Pandemic is a programme that the Royal Society set up back in March when we first started entering lockdown, that kind of period in the pandemic. And as it says here, using the power, the influence of the Royal Society to try to put together some scientific teams to accelerate the response, and particularly scientific advice to government and those sorts of questions. So, one of the things they asked, which was quite an interesting kind of perspective and question, was for people to think about, what happens if we look at this pandemic, not so much from the health kind of point of view explicitly that people tend to focus on, but if we kind of from the angle of social behaviour and contact. This is an epidemic that is clearly it's a communicable disease. For it to take hold, then that depends on where people are, how they're moving around, how they're interacting with one another, and of course that in itself has formed the basis of much of the policy and approach to interventions since then. So start off with what happens if we want to go back to something like our microsimulation model and think about adding new variables particularly relevant to that infection status. So how can we use these microsimulation approaches to introduce this as a characteristic of the population? Then how can we start to do similar things to before in terms of moving people at the right hand side of the diagram here into environments around shopping, working, schools, leisure environments, all that kind of thing. So again, combining our microsimulation models with space interaction models of movement and behavior that will then provide the conditions in which infection can spread potentially in explosive ways in a dynamic geographical context. So this, I should say, is a piece of work involving, as again, I'll say, Leeds and UCL, as well as Cambridge and Exeter. And so, for example, just go up and down again, you can see in the illustration here, which is for Exeter and surrounding region, how we can develop a model that starts to track the growth, spread, diffusion, and ultimately control of the pandemic. And we think that this work is, potentially, or well, very close to being actually extremely important and valuable in the current context, where we're seeing a lot, of course, about the spread, but also within a spatial context. The issues around Leicester, other kinds of towns and cities. There's an increasing narrative about how if we start to see a second wave, this is going to play out and get controlled locally and all these kinds of issues. And so a modelling approach, particularly a scenario-based approach to this sort of problem, is very important. And we just see an illustration here where we're saying on the left-hand side, okay, we can simulate, model, reproduce the spread of an infection. What happened when we lock it down? It starts to grow quickly. We can get that under control. Maybe if we'd done that even earlier, then we can, of course, start to exert even more control over this, and then start to think about extending this idea to other interventions and possible actions. Okay, so there's the second example. I'm moving to a conclusion. I couldn't resist having one slide on, again, something that a lot of you will see, number 10, data science. But this idea that's been in the press that the government is going to set up a data science unit, and it's actually starting to recognise, if you look at what Michael Gove says at the bottom right-hand corner there, the fact that the government is starting to recognise that it needs real data and evidence about what's going on in things like coronavirus, but not just that, and how can you use that, that data, that evidence to influence those policies and decision making. And I do think that this is bang in line with the kind of argument and approach that I've been outlining and advocating here. So it's perhaps promising that that senior members of government are starting to open their eyes to this and may be increasingly receptive to the sorts of things that this work is able to bring to the table. So given time, I won't dwell on the conclusion, which isn't very sophisticated anyway, but to recap what I've said about urban analytics, I think it's a set of methods and approaches, but very strongly connected to wanting to use data, big data sources, convert that into real world understanding and often policy support and interventions in the world. I think there is, those approaches are more relevant, and there is increasing recognition of that, particularly in the current situation that we face. And it's more important, therefore, more important than ever, that I think we bring some ambition, some creativity into this space. And so it's not just about knitting together these data sources in a technical sense. It's about thinking how we can use things like AI and data science to really extract the value and the influence from these methods and approaches. I've gone on 10 minutes longer than I probably intended, but it was ever thus. Can I get back? Adam, I've stopped sharing.
Am I back?
I can see you, I can hear you.
Oh, great. Okay, fantastic. Thank you, Mark. That was brilliant. I mean, I really enjoyed kind of historical overview and particularly your this kind of framework of data models and insights. And so, if anyone's got any questions, you can kind of add them into the chat bar. I will sort of kick off while people are typing, I guess. And I was interested, sort of going back to this sort of data models, insights framework, and I wondered sort of whether your experiences of spending a sort of decade or so in the commercial world, how that sort of shaped what you do now as an academic. And particularly sort of, I guess a lot of people in this room will be PhD students sort of looking to sort of move on after their PhDs. And I sort of wondered whether, if the route that you took sort of out of academia back into academia is one that you would recommend, if it's helped shape your sort of intellectual agenda and that sort of thing.
Yeah, well, I mean, so the short answer is, yes, it's absolutely helped shape my intellectual agenda. I mean, also actually, I mean, this is kind of by the by, but just generally, I suppose my approach as an academic, as you said, we set up the Institute for Data Analytics, leader in Leeds in 2013, 2014. Very much as wanting to create an institution, an infrastructure for bringing in data, applying models and that kind of thing. But the point is, wanting to do something in a, I guess, kind of in a more kind of a team, a community sense, not just as an individual academic. And that's one of the things that, I guess you pick up when you work in business. Is it not so much about just your individual contribution? It's about maximizing the contribution of the collective. I guess in terms of approach, it's a bit double-edged. You have to be slightly careful about not being too utilitarian about things, because you will get drawn into that sort of thing in a commercial environment where where a customer is paying you to do something and they jolly well expect it to be delivered. And there are elements of that again when we get into the current kind of policy debates. You start talking to government, they say, okay, there are things that they want you to do. It may be worse than that. They might want you to to demonstrate certain kinds of outcomes or draw certain sorts of conclusions. But on the other hand, I think that relevance is important, and if you want to get backing for your research, I feel we need to be engaging with those kinds of debates. So we need to strike a bit of a balance between the research, the academic freedom, asking good questions, hard questions, but finding that pathway to relevance that informs people, but yeah, we've seen a lot of that in terms of the scientific conversations around COVID, haven't we? Is the scientists, try and have an independent say, but you can see very publicly that battle between the scientific and the and the government sort of perspective.
Okay, I see some questions coming in at the bottom now. So Simon's just asked, what would you have added to the geospatial strategy to address better the use of geospatial data and intelligence?
Well, now I'm thinking back, and that's to what's actually in it. But in broad terms, models, AI, data science. I mean, I don't want to be too critical of what's actually in the strategy. And as I say, the presentation I was at, I heard lots of good things in terms of people's intent, and recognise there is a little bit of an issue here in that if you're sitting sitting somewhere trying to write and put together a strategy, you're looking round for good examples, case studies, illustrations, this kind of thing. And some of the things that I'm talking about, and this is a bit of the issue, there's not as much out there as we might necessarily like, but it would be nice to see a little bit more kind of case study around those kind of AI modeling type questions. And I guess maybe just a little bit more focus on the outputs rather than the inputs. Again, a classic kind of dilemma, but what's coming out, how can it influence things, rather than all the how can we get more sophisticated data sets, inputs, blah blah blah.
Okay. Question from Karen. And this probably chimes with your CDRC hat a little bit. Should the public and private sector be sharing more data with academia?
Oh my word! So should the did you say public and private?
Private sectors be sharing more data with academia?
Yes, in very big letters. But I'm involved in quite a lot of conversations, as you know, Adam, in and around various kind of government offices and ONS and all that sort of thing. And some of it's in the news, of course, isn't it, around the more kind of public health data, and we know that there are huge issues there. I mean, with the public health data, it's around primarily concerns, and important concerns around privacy and ethics and those kind of questions. In the private sector, it's a bit more around sort of commercial concerns and confidentiality from that point of view. And although again there are issues about the rights of ownership and all those sorts of questions. So it's difficult, and it's a bit of a legal minefield. But having said that, to my mind, the answer is yes. There is a lot of hiding behind some of that, because people don't want to do it, even though if we could get access to finer grained data from whoever, mobile telephone providers, financial service organizations, retailers, about not specific customers but patterns of behavior, that would really help quite a lot in terms of understanding, again, particularly the COVID thing. And that then pushes back to, as you say, the CDRC question. I mean, this is what we've been saying about for years about, it could be helping us to understand, for example, those Mistral type questions about housing and labour markets and unemployment and all that. So absolutely yes, and I'm hopeful that people might start to recognise that a little bit more, just given where we are, and there's some evidence of that.
Do you think the CDRC is sort of well positioned now in this new sort of context to sort of take advantage of all of these, the kind of the need for better understanding of human behaviours more generally?
I mean, you'd hope so, because I say we've established the infrastructure. It's been going. It's well into a second phase now, so we were going for 6 years or so. And I feel this is what we've been trying to do during that time. So we kind of got the infrastructure established. And if we could just turn the tap on a bit, a bit harder, then I think we would be well placed. So, we'll see. And I mean, the ESRC still has got it on their agenda to build up the investment, I think. So it could be a real springboard. It'd be nice to think so.
Okay. Slightly contentious one from Andrea. So during the COVID pandemic, we've seen how hard it is to disentangle science from politics, particularly when top scientists advise governments on critical issues. How have your personal political ideas influenced your work in urban analytics? Don't ever get into politics.
That's interesting. I mean, I think all I'd probably say for that is, we go back to what we were just saying about the CDRC. I think he's going to go on that. The previous question, really. I do believe that we should be finding ways. There should be ways found to encourage organisations of all kinds to share data in the public interest. I probably wouldn't want to go too much further than that in terms of disclosing or debating my own political beliefs, but I think it's just not good enough to say, oh, it's commercially confidential, we own it, you can't have it. If you can, save lives ultimately, or improve the quality, the returns from public decision making through better use of those kinds of assets, you should jolly well be doing that, in my opinion. But there's an extent to which, even in making a statement like that, you bleed into political judgments rather than scientific ones, inevitably.
Okay, question from James. How will new technologies influence urban analytics? So 5G, quantum computing, all of those sorts of things. What do you see as the future there?
Oh, crumbs, that's an interesting one. I do come back to, again and again, that I think data is the crucial issue. So the fact that we are, just generating so much more, high quality data, and ultimately as social scientists, I mean, it's kind of a different talk, but it's a thing that's held us back more than anything over the last 30 or 40 years. It's actually not our imagination about our capability to model things and to generate theory. We're really good at that as academics, but it's embedding it in the evidence. Did that actually happen? Why not? What if? Those sorts of questions. The COVID thing is interesting. I mean, the RAMP project, again, as you know, Adam, but we're trying to scale that up to simulations for the UK, that might be running on a daily basis under various kinds of alternatives, scenarios, ensembles, all that kind of stuff. It can potentially eat a lot of computing, but I'm not sure I would regard that as fundamentally transformative. I mean, I do think the whole artificial intelligence thing, I could kind of go both ways on. Sometimes you look at it and it's just black box, dark magic that's being dressed up as something that possibly isn't. But on the other hand, again, you come back to that. If I'm trying to understand what's happening to an epidemic in a very granular sense across a nation, across a set of communities, proper artificial intelligence, whatever that is, a machine that thinks and can look at stuff in much greater detail and much more easily than a human observer, there's some scope for that. But I think my sense is that we're a long way from actually being able to realize that, and in some ways the problems that we're looking at are just more complicated, more nuanced than trying to recognize a face or teach a computer to play chess or Go or that kind of thing. But I think there's a lot more that we could do.
Have we got time for one more question, Andrea and James? We've got last one from Anna. Just 2 o'clock is ticking over. So what distinguishes urban analytics from any other spatial data analytics? Have we customized, developed new models for data with higher complexity and frequency of data?
Okay, you're going to force me to be equivocal if that's the last question. I think in a lot of ways, I'm kind of, I want to say I'm not big on labels, I mean, but in a sense I am. I mean, you know, I've latched onto the digital twin thing. You know, I've talked about urban analytics. You know, I wouldn't want to distinguish it from, you know, spatial data or, you know, that kind of associated stuff. You know, all these things I would just see as kind of framing. You say in the context of the Turing, you know, one of the issues is to say, you know, what does the Turing do? You know, it does AI. You know, it's got a policy program. It's got a data-centric engineering program. You know, because I'm a geographer and because I'm here talking to this room, you know, I think that spatial analysis is really important. You know, the way that we've chosen to frame that with the Turing is to call it urban analytics, probably because we feel it's got a bit more legs at the moment than calling it spatial analysis or the Turing's geography program. But you know, I don't think that in itself changes the agenda. You know, whatever we call it and wherever we see ourselves coming from, you know, what we need to do is to, you know, develop better, more applicable stuff. You know, do the kinds of things that I've been talking about. You know, in my opinion. So whether you call it digital twin, urban analytics, spatial analysis, geography, something else, it's horses for courses. It's what you're trying to get out of it, I think.